Hello, today in this lecture we will discuss about the topic differentiation for doing physics numerical problems of class 11. So to get into the topic, first we need to know what is a constant and what is a variable. This is class 5 level things. Constant is something that value remains unchanged with time. Example 10 minus 5, 7, 2 by 3, pi, etc. So value of 10 is always 10 and value of 2 is always 2. It never becomes 2.1 or 10.1. Then what is a variable? A variable is something that whose value may change with time. Let's say example xy. The value of x may be 1 in one problem and 2.7 in another problem. Next, definition of time. Can you tell me the definition of time? Let's see. Whenever you try to construct a definition of time, you will find that you have to use the word change in time. You cannot derive a definition of time without saying the word the change in time. So actually there is no proper thing called definition of time, or there is actually the definition of change in time. So for doing calculus we take what? Small change, and in class 11 problems we basically take small change in time. So it's from the word small change we will slowly enter the concept of derivatives. Now v equals we know what velocity equals to displacement by time. So if we take the displacement very small and the time change in time also very small, this can be written as small change in time ds by small change in time dt. ds is small change in displacement and dt is small change in time. Similarly, acceleration is change in velocity by change in time. So acceleration is small change in velocity by small change in time. Next, what are functions? Dependent variables and independent variables. We also have gone through in class 9. Suppose y equals to 5, if x is a relation. If x can be anything, let's say sin x, cos x, or a polynomial of x square plus bs, quadratic polynomial, or a higher degree polynomial, 6 to the power 4 plus 2x square. Then we can say y is a function of x. Clearly y is a function of x and y is a dependent variable, x is the independent variable. I am getting into reasons another end for revision. Y equals to fx equals to x plus 2. If we put the value of x equals to 0, if 0 equals to y becomes what? 2. And if we similarly we put the value of y x equals to 1, then the value of y is 3. So we can see the value of, we are taking the value of x is independently, but value of y is changing due to the value of x. We have solved this kind. Now we are taking this y equals to x plus 2 and plotting this on Cartesian plane. So when x equals to 0, y is 2, when x is 1, y is 3, when x is 2, y is 4. We just put plotting it on the Cartesian plane, xy plane. So we are getting this 1 a 0, 2 point, b 1, 3 point, c 2, 4 point. We can on the similar manner we can plot y equals to sin x curve. This is a periodic curve. So there is a plotting of y equals to sin x. At x equals to 0, sin 0 is 0, at x equals to pi by 2, sin pi by 2 is 1, and again at x equals to pi, sin becomes 0, at 3 pi by 2, sin becomes 1, and it's go on similarly like this. This is the harmonic wave and a periodic function. Similarly, if we put plot y equals to x cube curve, this will look something like this, and we y equals to x to the x square, we plot, this will look something like this, and if we increase the power of x, then the curve will go closer and closer to this y equals to 0 line. And for similar way, if we plot y equals to x cube, this curve, this will look something like this green line, and if we increase the power of y, this say y equals to the power 5, this will go closer to this y equals to 0 straight line. Next, now we have to see one thing. When we are plotting, we have mainly discussed about two things. We have discussed till now about one thing: y equals to mx plus c straight line. Plotting of y equals to mx plus c straight line. This will look something like this. Why this in y equals to mx plus c straight line? M is equals to the slope of the line, and here's this, in this plot c is equals to 0. Now for x equals to 1 we'll get f1, and x equals to 2 we'll get f2. This distance is equals to what? 2 minus 1, 1 units, and this distance equals to what? F2 minus f1 na, because this point is 1 comma f1, and this point is 2 comma f2. So this, not this distance is f2 minus f1. Similarly, this is a straight line. For a curve, in a curve, see, in a straight line the slope is always the same, but in a curve the slope is always changing, and slope can be also written in m equals to tan theta, but this is theta, right? Here this distance is 2 minus 1, and this distance, I am coloring it with yellow, this distance, there will be something distance like this, which is obviously equals to f2 minus f1, because this point, coordinate of this point is 1 comma f1, and coordinate of this point is what? 2 comma f2. Next, the topic we have need to what does means del x and del y. This is basically very small change. The smaller you can think, even smaller than that. Say 0.001 or 0.001 to the power 10. So the change is so small it can be said as negligible in class 10 or lower classes. We write this as del x, del y, del z. Change, this change part is said 0.001 is del x. This change part is said del x. We actually write it like this, dx, when x by dy or dy, dx or dy. This is actually equals to the operator of differentiation. We differentiating x with respect to y. We'll discuss this later. Okay. Next, we have taken in what is now we are getting to the derivatives. We have already discussed all these topics. See, if we consider 2 points ax1 comma y1, bx2 comma y2, and the straight line is a straight line. These are 2 points on a straight line. Then slope m equals to what? From class 11 standard we know slope m equals to y2 minus y1 by x2 minus y1, which is obviously equals to tan theta. Here this is the angle theta, and this is the distance between y2 and y1, and this distance is represent x2 minus x1, and this is a Cartesian plane, xy plane. Now instead of a straight line, if we consider a curve, the slope is not equal. I have already told you. This means we need to measure the slope. We need to take 2 points within a very small distance, the curve between these 2 points. Consider a straight line. Now say we are taking these 2 points on the curve P and Q, x and y, and Q is del x and x plus dx plus y plus dy. Basically we are taking very small at points at very small distance, so we are taking x plus dx is very small change in x or increment in x, and dy is very small change in y or increment in y. So this distance, if this forms this like kind of triangle like this distance becomes equals to del y, y plus del y minus y equals to dy, and this distance becomes equals to x plus dx minus x equals to del x. So I have already told, in a straight line we are taking 2 points x and small, take as first, and we are considering from this a straight line, and as another point coordinate of x in another point x plus dx, because we are taking small change in x. Del x is what? Increment of x. Similarly y and y plus del y, where del y is small change in small increment of y. So the points are what? X comma y and x plus del x, y plus del x, and the function is y equals to fx. So clearly the del x by del y equals to dy by dx equals to tan theta. This is the slope of the curve. Now this dy by dx is actually what we mean by differentiation. Now the derivation. So we can now write del y equals to f of, because the coordinates are y, x comma y and x plus del x comma y plus del y. So we can write del y equals to what? Since the function is fx, f of del y equals to f of, by previous assumptions, del x minus fx na. Now dividing this by del x, we know del x equals to what? Can be written as x plus del x minus x. So I have just divided it by del x. Now as del x tends to 0, del x is, when the increment of x is very small, so as del x tends to 0, this is the main convention. This lim x tends to 0, lim del x tends to 0 becomes dy by dx, which has, can be written as f dash x, which is derivative with respect to f. Change, actually f dash x is y, change of y caused by unit change in x. We are taking small, and because in the curve, this is a curved line or straight line, 2 points, we are taking a small, very small change in x with respect to y, getting a very small change in y. This is what is the concept of differentiation is. The small change, by this small change, is actually derivative of x, where del x tends to 0, and increment of x tends to 0, and increment of y also tends to 0. So we can write element x, del x tends to 0, del y is equals to dy by dx equals to f dash x. This increment of x, we have already considered our increment of y is very small, smaller than we can even imagine, right? Next, now we will discuss some important one important formula for doing, basically we will discuss this topic for what, for doing problems of physics numericals. So we will discuss an important formula which will be needed in all the problems. Then the formula says that d of x to the power n, degree of x is n, is n x to the power n minus 1. So dd of x to the power 6 becomes what? 6 in this n is 6 x to the power n minus 1, x to the power 6 minus 1, so 5. Similarly, x to the power dd of x to the power 8 minus 1. Here n is what? Minus 8. So you have written minus 8 x to the power n minus 8 minus 1. So minus of 8 to the power x minus 9. Similarly, x to the power dd of x to the power 1 by 2. Here is half is n. So x to the power half minus 1. So this becomes 1 by 2 x to the power minus 1 by 2. Next, in general, obviously there will not be everywhere x to the power n, and the constant term will be 1. Basically, when we are doing problems like x to the power 6, x to the power minus 8, there is a constant 1 multiplied with it. If there is a constant, say a can be anything, 2, 3, what this happens, just a is, because since a is constant, we doesn't differentiate with time, because we already have in the beginning of the lecture we have discussed what value of the constant does not change with time, value of the variable changes with time. So if we differentiate constant with time, the value does not change. Even the differentiation of a constant gives 0, because value of a constant does not change with changing in it, with respect to change of anything. Here with respect of change of, say, x, so differentiation of any constant gives 0. But for in this case, the constant is multiplied by the variable, so the constants go on onto the left side, say, and the differentiations go on like ddx of nx x to the power n, what we do. So this becomes a into n to the power x n minus 1. So similarly for ddx of 6 x to the power 7, what, this 6 term this constant, this value of this does not change with time, but value of this part changes with time. So we do dd of x to the power 7. This here n is 7, n comes out. Also x to the power, this will be 7 minus 1, sorry, this will be 7 minus 1. So 7 minus 1 is actually equals to 6. So this will be 6 into 7 42 and x to the power 6 answer. So we're done with our lecture. If you like it, do like it, and please subscribe and share. Later on another lecture we'll talk of the basic concepts of integration, because we need this need to know this concept for doing the problems of physics numericals of class 11, for finding out velocity, instantaneous velocity, acceleration, displacement. For many things we will need to know the how to why we're basically doing the integration and differentiation, and try to apply them correctly. So thanks for watching.